In this video, we're going to look at the Test 4 review. And so we have 23 questions that we're going to work out in a series of videos here. So in question 1, we want to list all the ways you can select two different coins from a group of 4 coins consisting of a $half H, quarter Q, dime D, and nickel N. The order of selection is not important, so HQ is the same as QH. So again, we're supposed to list the ways that we can end up with two different coins out of those 4 coins. Well, we could select the $half and then the quarter, or we could select the $half and the dime, or we could select the $half and the nickel. So if the $half is selected, again, it could either be with the quarter, the dime, or the nickel. And these are the only outcomes in which the $half is included. Now we could also have the quarter with the dime, or we could have the quarter with the nickel. And again, we already have the quarter with the $half here. And then we could also have the dime with the nickel. And we already have the dime with the quarter. We already have the dime with the $half here. And then we already have the nickel with the dime, the nickel with the quarter, and the nickel with the $half. So these are the only 6 possible outcomes. So if we have 4 coins and we're picking 2, it can be one of these 6 outcomes. We could end up with the $half and the quarter, the $half and the dime, the $half and the nickel, the quarter and the dime, the quarter and the nickel, or the dime and the nickel. So those are our 6 possible outcomes. Let's take a look at question 2. The game Dungeons and Dragons uses a tetrahedral die that has 4 congruent triangle sides numbered 1, 2, 3, and 4. If you were to draw a tree diagram to show the number of ways that 3 tetrahedral dice could be rolled, how many branches would it have? So if we roll 3 tetrahedral dice, and so again, a tetrahedral dice has 4 sides. So if we roll 3 of them, the first die could land in 4 ways, the second die could land in 4 ways, and the third die could land in 4 ways. So there would be 4 times 4 times 4, which would be 64 different branches on the tree diagram that we could use to illustrate all of the outcomes. So there would be 64 possible outcomes if we roll 3 tetrahedral dice. Let's take a look at question 3. An outfit consists of a shirt, pants, tie, and jacket. So we have to have one of each of those, a shirt, pants, tie, and jacket. If you have 5 shirts, 4 pairs of pants, 6 ties, and 2 jackets, how many different outfits can you make? Well, here we're just going to use our multiplication rule. So again, we have to have a shirt, and we have 5 shirts to pick from. We have to have a pair of pants, and we have 4 pairs of pants to pick from. We have to have a tie, and we have 6 ties to pick from. And we have to have a jacket, and we have 2 jackets to pick from. So there's going to be 5 times 4 times 6 times 2 different outfits that are possible. And so if we multiply that out, 5 times 4 is 20, 20 times 6 is 120, and 120 times 2 is 240. So there would be 240 different outfits that would be possible. Let's take a look at number 4. The Rock Climbing Club has 14 members. If the club wants to select a president, vice president, and treasurer, all of whom must be different, in how many ways can this be done? So we have 14 members, and we're going to pick 3 of them. So one will be president, another will be vice president, and the third will be treasurer. So we want to know how many ways can we do this. Well, one way to think about this is a permutation. We have 14 items and we're going to pick 3 of them. The order in which we select them matters because the first individual will be president, the second will be vice president, the third will be treasurer. And so this is a permutation of 14 items and we're choosing 3 of them. So this is going to be a permutation of 14 choosing 3, so we could denote that this way, or if you'll remember, we also have our notation permutation of 14 choose 3 this way. So if I bring in my calculator, if I type in 14 math probability permutation and I'm selecting 3 of them, that would be 2,184 ways. So there would be 2,184 different ways that we could select the president, vice president, and treasurer. Let's take a look at number 5. The Early Bird Special at TGI Fridays consists of an appetizer, entree, and dessert. If there are 4 appetizers, 12 entrees, and 6 desserts, how many different meals are possible? Assume that you have to make a selection from each category. So we have to select an appetizer, we have to select an entree, and we have to select a dessert. So again, this is just going to be our multiplication rule again. So again, we have to choose an appetizer, and there are 4 of those to pick from. We have to choose an entree, and there are 12 of those to pick from. And we have to choose a dessert, and there are 6 of those to choose from. So there's going to be 4 times 12 times 6 different meals possible. So if we take 4 times 12, that is 48. And 48 times 6 is 288. So there are 288 different meals that are possible. So again, that's just our multiplication rule. Let's take a look at number 6. Professor Harried is overseeing this semester's theater production. She needs to select a producer, director, and stage manager. There are 6 students to select from for the role of producer, 3 for director, and 5 for stage manager. In how many ways can she select the students to fill the roles? So again, this is basically the same as the previous kind of problem. We need a producer, a director, and a stage manager. There are 6 students that could be producer, 3 that could be director, and 5 that could be stage manager. So how many different ways can she fill these roles? Well, that's just going to be 6 because there were 6 students that she could pick from to be the producer, times there are 3 individuals who could be the director, times there are 5 individuals that could be the stage manager. So if we multiply that out, 6 times 3 is 18, and 18 times 5 is 90. So there are 90 different ways that this professor could fill the roles of producer, director, and stage manager. Let's take a look at number 7. A campus bus must travel from a dormitory, D, to the student center, S, and then to the fitness center, F. How many different routes are there from D to F while passing through S? So we have to go from D to F, but we have to stop at S. So we're really going from D to S, and then we're going from S to F, and the question is, how many different routes are possible? Well, so to figure this out, we're going to figure out how many routes are possible from D to S. We're going to figure out how many routes are possible from S to F, And then we can multiply those two things together to get the total number of routes. So let me write down number 7 here. I'm going to scoot this off to the side a little bit so we can see both my paper and the map that's shown here. So this is a combination problem. In order to get from D to S, now we're going direct. So it says how many direct routes. So we're not going to go backwards or anything like that. We've seen problems like this before. So in order to go from here to here, we're going to move 1, 2, 3, 4, 5, 6 different blocks. And 3 of those blocks are to the right and 3 of those are down. So this is going to be a combination of 6, and we're choosing 3 ways to the right or 3 ways down. So this would give us the number of paths to get from D to S. So this right here is telling us the number of routes from D to S. That's what this combination's telling us. Now, to get from S to F, we're going to have to go 1, 2 blocks to the right and 1, 2 blocks down. So there's a total of 4 blocks that we have to travel. So to get from S to F, we're going to travel 4 blocks, and 2 of those are to the right. So this here is giving us the number of routes from S to F. And so if I find those two things and multiply them together, that would be the total number of routes possible to get from D to F, stopping at S. So if I bring in my calculator, I can find 6 math, probability, combination, choose 3, that is 20. So there are 20 routes from D to S. So this is 20 times. In the same way, if I do 4 math, probability, combination, 2, so there are 6 routes from S to F. So this is 6. And if I multiply 20 times 6, that's 120. So there are 120 routes possible to get from D to F passing through S. So take a look at number 8. Assume that we want to seat Alex, Bonnie, Carl, Daria, Edith, and Frank in a row of 6 chairs. And how many different ways can the seating be done if Alex and Bonnie must sit together? So we have to have 6 chairs. So we have 1, 2, 3, 4, 5, 6. Now if Alex and Bonnie didn't have to sit together, then we could do this 6 times 5 times 4 times 3 times 2 times 1. It would just be a matter of 6 factorial different ways. But we're complicated by the fact that we have to have Alex and Bonnie sitting next to each other. So the question is, how many different ways could Alex and Bonnie sit together? Well, so for example, if we have Alex and Bonnie here, that would be one way. Or we could have Alex here and Bonnie here, that would be 2 ways. Or we could have Alex here and Bonnie here, that would be 3 ways. Alex here and Bonnie here, that would be 4 ways. Alex here and Bonnie here, that would be 5 ways. So there would be 5 different ways that I could put Alex and Bonnie together if Alex is on the left and Bonnie's on the right. But then there would also be 5 more ways that would exist if Bonnie's on the left and Alex is on the right. So this could be BA, 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 BA. So there's a total of 10 different ways that I could sit Alex and Bonnie together. So there's 10 ways that I could group Alex and Bonnie together. Now for the others, so on top of these 10 different ways that Alex and Bonnie could sit together, then for the 4 remaining empty seats, the first empty seat, there would be 4 of the others that could sit there, and then there would be 3 of the others, and 2 of the others, and finally the last one. So there would be 10 times 4 times 3 times 2 times 1. different ways that I could sit these 6 people if Alex and Bonnie have to sit together. Well, 10 times 4 is 40. 40 times 3 is 120. And 120 times 2 is 240. And 240 times 1 is still 240. So when I multiply that out, that is a total of 240 different ways that I could sit these 6 people, again, if Alex and Bonnie have to sit together. And just one more time for clarity, if we didn't have the restriction that Alex and Bonnie had to sit together, then it would just be 6 times 5 times 4 times 3 times 2 times 1, so that would just be 6 factorial. But the fact that these two have to sit together limits that, and so we end up with 240 different ways. So let's end this video, and we'll pick up with problem number 9 on the next video.